Hello, I'm Mr. Tappy, and thanks for watching my second video, or part 2 of one-dimensional motion, and we're looking for the change in y. In our last video, we found out that, let's see if I can get it right here. We found out that the vertical velocity, or at least the component of our original 60 meters per second that went into making the arrow go up, was actually 30 meters per second. And so, picking up where I kind of left off there, alright, and here we are. So, we know that our initial velocity, of our y component is equal to 30 meters per second. And basically we just did that using trigonometry, sine, cosine, and tangent. So here we are. Now, we've taken the vertical component of our arrow going upward. Okay, we've taken it off. And so basically, this is the equivalent of anything, any kind of projectile flying upwards. So, the arrow, pretend the arrow is launched, or pretend it's a ball or any projectile, and it is launched, at an initial velocity of 30 meters per second. Once it gets to the very top, just like anything else, it's going to rise up, gravity's going to overtake it, it's going to pause for just a moment, and at this exact moment, we know that our final velocity of this object is equal to 0. So at its maximum height, the arrow will reach a final velocity upward of 0. Now that's still going to the left and right, but as it starts to go up, at some point here, it's no longer going to be going up, and it's going to start going down. So if you look on this side, everything's going up, it's going up. Once we get to this point, we have begun our downward descent. So at this exact point, it is no longer rising up, final velocity is 0. So final velocity is 0 and initial velocity is 30 meters per second. We can start to fill in our other blanks. Now we are looking for our change in y. That is the thing we are looking for. And we know, because we're on Earth, that gravity, of course, is our acceleration. And gravity, since it is working against us, it is negative 9.8 meters per second squared. So we're going to go look at our kinematics equations, and they are all right here, so I have them listed for you. And as you can see, we'll have to go through the list and figure out what exactly we can and cannot do. I'll pick a different color. Alright, so as you can see, we're looking for a change in y, and remember, a change in d, the y is a specific type of a change in distance. It's talking about the component that goes up and down. And so basically, we can just change this d to this y, and we can go ahead and get started. So do we have a change in y, or a change in displacement? Yes, we do. Do we have an initial velocity? Yes, we have one right there. Do we have a time? Well, no. But we could be missing one variable. And do we have an acceleration? Yes. And we're missing a time. The problem with this is that we are missing, in this example, we are missing actually two variables. We're missing the d here and the t. Remember, we can't work a problem in algebra without having just one variable missing. And so this one is no good. We'll go to the next one, and we'll see we have a final velocity, which is 0. So we have that, yes. We have initial velocity, yes. We have an acceleration, yes, but not a time. But we're not looking for time, so we can't use that one either. And that leaves us to the last equation. So we take all our numbers that we have our final velocity, which is 0, and we just plug them into this one. So we have 0 squared equals initial velocity, which is 30 squared, plus 2 times a, which is negative 9.8, times our change. And remember, we can change this to y because it's more specific. It's talking about our up and down component, or vertical component. So 0 squared is still 0. I'll move everything kind of over a little bit. 30 squared, so we have 30 times 30, which is 30 squared. 3 times 3 is 9. We have 1 and 2 zeros, so 2 zeros. And we have plus 2 times negative 9.8. So positive 2, negative 9.8, that's going to equal negative 19.6, and we multiply it times our change in y. At this point, we're going to take our 900 and get it to the other side. So we subtract 900 from one side and the other. This cancels out, and we end up with something that looks like 900 equals negative 19.6 times times a change in y. We have to get rid of this 19.6, so we divide by negative 19.6. These are going to cancel out, and what we do to one side of the equation we also do to the other. These negative divided by negative is going to cancel out to become positive, and what we're left with is 900 divided by 19.6. So we'll turn on our handy calculator, and we will do 900 divided by 19.6. So we have 45.9. And so our change in y, and I'll go ahead and put the y first because it looks better, equals 45.9 meters. I hope you enjoyed this video. Thank you for watching.